Now let's look at the code which showed us the graph, which told us the nature of roots on its own, right? So let's look at that. So this is your code, and let's copy this onto the screen so that it's easier to discuss. So now there are a few things that we are not discussing, and there are only certain things that we are looking into. First is noticing A, B, and C value. That is, we are looking at the coefficient of x square, coefficient of x, and the constant. So we're taking in the inputs. Post that, we're calculating determinant, that is D. So D is calculated over here as B square minus 4 into A into C. Is it not? B square minus 4AC. And then we're jumping off the function part. As of now, let's not look into that because this will be executed when it's called. So that is something which you will understand in time, but let me move on to the next part, that is nature of roots. So nature of roots, first line is to print that, okay, we're looking at nature of roots, right? That's what the print statement is about. And we are looking at the condition statements now. If D is less than 0, right? That's what after doing D, that's what we do now. So to understand this part, I have made a flow chart. The program starts, they execute few things in between, and then it's looking at if D is less than 0. If it's so, then it will execute print roots are imaginary. Okay, so this section of code will be executed and the program will jump out of the loop. This is your end. So it will jump, execute this, and directly jump. It won't execute any one of this, it will jump out and it will end the program. Say if this was no, right? Then it won't be executing this set of codes. Okay, so it won't be executing this set of code. It will just execute this, not this. And next it will look else if D equals to 0. Now it will tell the roots are equal. So we're looking at yes. If the condition is yes, then the roots are, it is telling the roots are equal and it will calculate the roots. So how does it calculate the root? So you can see alpha is calculated as minus b is the bracket plus d to the power of 0.5. Right? Double star means to the power of, that is nothing but square root of t. Right? 0.5 is nothing but 1 by 2, that is nothing but square root of t. I have closed the bracket over here, you can't see that, divided by 2 into a. Okay, that's how we determine alpha, and beta is minus b square root of d divided by 2 into a, right? So that's what we're looking at, and then it will display and stuff, and then it will end the program. Say this is this condition is also not true, right? And next is else. Actually, this condition, there's no further condition that will be checked directly. It will execute, calculate the roots, and it will display the graph. So this is what we are looking at, right? So what we are coding, the way we are coding is the logic is same as what we do on the paper. This we write, is it not? This we make a note of A, B, and C. Then we calculate D, and then mentally we'll check this set of conditions. And if it's whatever condition is satisfied, we might end up calculating alpha and beta, and that's what the program is also doing. Is it not? So coding is not way different. I mean, not different than how we think. Coding is also a way of teaching the computer of what we do. This is in a systematic manner.